All right, welcome to back, and we're going to talk about 6.2, transforming probability distributions. Key things that you need to know about probability distributions is when you're adding a c, when you're transforming them. When you're adding the same constant c to each value, we have to know that the shape stays the same for the distribution. The center, we add the c, and the variability stays the same. Very, very similar to when we did these distributions earlier in the year. Same way as you say, multiplying the same constant c to each value. The shape will stay the same. The center is multiplied by c, but now the variability we multiply by c here. And so our standard deviation, which is our delta, is going to be c times delta. Whereas in the variance, which is essentially the standard deviation squared, we take c delta our standard deviation squared, which is c squared times the standard deviation squared. So let's try some problems out and kind of talk about this a little bit more. All right, so here we go. And let me get my writing utensil ready to go. What we have right here is a large auto dealership keeps track of sales made during each hour of the day. Let X in the number of cars sold during the first hour of business at a randomly selected Friday. Based on previous records, probability distribution of X as follows. So 0 cars sold, 1 car sold, 2 cars sold, and 3. 0.3 probability, 0.4, 0.2, and 0.1. All adding B equal to 1. All right, so we know this is a proper probability distribution. And so now the random variable X has a mean of 1.1, a standard deviation of 0.943, and suppose the dealership manager says he wants to take a $500 bonus from the company for each car sold. Let Y, the bonus received from car sales during the first hour on a randomly selected day. All right, so here we go. Sketch the graph of X and Y. So let's do X first, okay? And what we're going to have here is we'll go 1.1, 0.2, 0.3, 0.4, 0.5, and so on and so forth. Now, these are the number of cars sold. So number cars sold. And we're going to draw this probability distribution. So we have 0 right here. And so we're going to have a value of 30. So it's going to be like right like that. And then we have another one, which is 1. Okay, so this is 1. 1's going to be 0.4. We have that right there. This one's going to be 2. It's going to be 2 right there. And then we have a 3. Okay, and 3 is going to be 0.1. And we can see how that distribution, that shape is. Now, when we add our y, so this is x, excuse me. Now we're adding our y, that is going to actually equal the bonus. Okay, so this is the bonus received. Okay, and so how do we figure out this bonus? Well, if you sold 0 cars, you have 0 bonus. If you sell 1 car, you have a $500 bonus. It's going to be a $1,000 bonus. And then right here with 3 cars, it's going to be a $1,500 bonus. Now the probabilities of each one of these bonuses are going to be the same as the probabilities down here. So it's going to be 0.3, 0.4, 0.2, and 0.1. And so when you graph this, all right, when we talk about the bonuses, essentially you probably can predict that when we have this, we're going to have this same type of, all right, it's going to be the same thing. It's going to look the same way as all the other ones. So we have 0 is going to be right here, which is going to be 30%. We have the 1 right there, which is going to be the 40. Again, right here is going to be 2, so it's going to be 20. And then we have the, upside down, that 2 would be 500. 500, and we have 1,000. And then right here, it's going to be 1,500. And that's going to be 0.1. And what do you notice about these different shapes? They appear to be the same. Shapes of each distribution is the same. And that's what we said before, and that kind of verifies it. Now, if we want to find the mean of y, well, how do we find the mean of y? If we know the mean is 1.1, okay, this new mean, all right, is we're actually going to take 1.1, all right, and we're going to multiply by 500. And so we can take this, multiply this by 500, because that's what we did, and that's going to give us our new mean for y. And so we take 1.1, multiply by 500, and that will give us our value. Well, I'll just move this down here. Whoop. Okay, and so what we have here is $550. Okay. All right. The manager spends $75 to provide coffee. All right. Well, that's the mean. I apologize. I found the wrong one. Just move that back up there. All right. So now how do we find our standard deviation? Interpret this. Well, our standard deviation of y is going to be the standard deviation of our x, and we're going to also multiply this by 500 because we are multiplying. And so what we can do here is we're going to take 0.943, multiply that by 500, and we get a new standard deviation of $471.5. Now, what is that? Well, we know that the bonus and so we know that the bonus received, all right, from car sales, typically varies by $471.50, all right, from the mean bonus, all right, the mean bonus, which we know is $550. Boom. Okay, so that's what we know. So a standard deviation is what we know is what typically varies from the mean. And so for our final question, it says manager spends $70 to provide coffee and donuts to prospective customers each morning. So manager's net profit T during the first hour on the randomly selected Friday is $75 less than the bonus earned. Describe the shape, center, and variability of the probability of T. Okay, so what we're doing here is that T is essentially taking whatever x is, and we multiply it by 500. But now we're subtracting that $75 from that. And so in order to figure out what is the mean of T, all right, or maybe we should talk about the shape first. Well, the shape is the same as x, as that distribution. We know the mean is going to be whatever that x is times 500, all right, minus 75. So in this case, we're going to take 550 minus 75. And so what we have there is $475. That's how much they actually earn. And then finally, we can figure out our standard deviation, okay, of T, which is going to be, well, whatever the standard deviation of x is times 500. But we do not subtract that, so our standard deviation of T is literally going to be the same as our other bonus. And so it's going to equal, right here, $471.50. And that's what we know. All right, and so those are the three things they're looking for T, which is the total amount they're making for the bonus. All right, well, I hope this helps you out on how to figure out transformations, and we're going to do another example in the next video.